Hello, folks. Welcome. Welcome to Planet's first webinar or weekly or bi-weekly weather webinar for 2026. It's great to have everyone here. Um, and today we're going to specifically talk about how to harness weather insights for resilient data center operations. A little bit about me. I am CEO and founder of Planette AI. I'm an Earth system scientist. I was formerly a fellow at the U.S. Department of Energy, also formerly a professor, still a working group co-chair for the Community Earth System Model, which is developed at the National Center of Atmospheric Research. Today, I have a really exciting special guest here. So, David Grantham is here as founder of Redwood AI. He is an expert in energy and the environment and has worked on both of these areas throughout his career. He's a Google Cloud Platform developer, a former executive at the National Research Consortium at Innovation Point Labs, and he's an Environment and Energy Leader 100 2019 honoree. So I have good company here to help me discuss data centers and their intersection with weather. So, jumping right into what we're going to be talking about today. First of all, I'm going to be talking about how data centers are vulnerable to the weather, what types of weather, and different types of vulnerabilities. From there, David will be telling us about how to harness these weather insights for adaptive resilience. He will present a model for adaptive resilience for data centers. And we'll talk about operational, financial, and community resilience components here. And then finally, I will provide some insights on the long range forecast over Q1 and Q2 2026 for different regions that have data centers. And this part will be really brief, and I'm happy to take any questions from there about further details of the forecast. So let's get started. So, as you probably know, data centers are very vulnerable to the weather. First of all, they're directly vulnerable to the weather, just like any type of sensitive infrastructure. So, there are episodic threats such as extreme rainfall and flooding, wildfires, severe storms, and then there are also the chronic threats, which are droughts and extreme heat. And incidentally, most of these are increasing as our planet warms. Data centers are also indirectly vulnerable to the weather, and this is because weather impacts the surrounding infrastructure and the environment, and this is an environment that data centers depend on. So, the most significant of these is probably the power grid. So, data centers have really high energy needs, and so during periods of high grid demand, the capabilities of the grid might be exceeded. And of course, extreme weather can always lead to power outages as well. And so, in addition to kind of direct impacts on the data center itself, that extreme weather may impact the power grid, which then impacts power sources, which then impacts the data center. The other major area is water resource scarcity. So, this is because most data centers rely on limited water resources, particularly in regions that are already arid. And in these regions, there's often competition for that water resource from surrounding communities, from agriculture, other industries. So, water resources can really be a point of contention and vulnerability for data centers. Adding to this are also ecosystem challenges and community friction. So we know that ecosystems are changing as our planet is warming. And so because of this, habitats are changing, species are shifting, and natural systems may be disrupted. Right. So, for example, if a particular data center relies on a particular river flow for its water availability, and this river flow is changing because of the weather, then that is going to have huge implications for the long-term viability of the data center. And finally, the community friction piece is also really important to keep in mind because, resources like power, water, land can be limiting. And so, whenever these limitations come to the fore, there's often conflict with the surrounding community. And so, this can also make life challenging for the data center. So, diving into these different vulnerabilities a little more. First, let's talk a bit about heat waves and cold snaps. So, on our warming planet, it's a bit surprising, but cold snaps can still occur. In fact, I'm going to tell you about one that's going to be happening in a couple weeks. It's showing up in our forecasts. And so, cold snaps still happen because you get Arctic air extrusions to regions that are not used to them, and so they are experienced as a cold snap. However, much warmer weather is the new normal. And so, because of that, for data centers, we know that cooling needs and therefore the energy needs associated with that cooling are going to be perpetual and they're on the rise. And power grid disruptions because of high demand, because of insufficient capacity on the grid, due to temperature extremes, these are becoming more common. So, heat waves and cold snaps are going to continue to be an issue for how data centers are operated and how they are vulnerable to weather. The next detail that I want to talk about is water. So, on our warming planet, the water cycle is just shifting enormously. So, first of all, it's really important to remember that precipitation is falling in much more narrow and intense events. And so you may have fewer of these events, but each event is much more intense. And so this is why flooding risks are higher now, for example. And it also means that because this precipitation intensity is increasing, it often means that dry seasons are longer because the precipitation is concentrated within sort of a shorter, more intense wet season. Snowpacks are shrinking, probably pretty obvious. But interestingly, hailstones are getting bigger. So the incidence of severe hail is higher, and this is because the updrafts and thunderstorms are getting more waterlogged. And so when there's more water in those updrafts, and when I say water, water vapor, um, they are amenable to forming larger and larger hailstones. And finally, runoff from snowpack or any type of mountain snow, it is happening earlier in the year. And so, because of that, often we're left with these long dry seasons where, especially at the very end of the dry season, we have issues with, say, hydropower or perhaps data centers or agriculture having enough water at the end of that season. And so, implications for data centers are, of course, going to be that weather related infrastructure damage. So, from that severe hail, from floods potentially. And because these investments may be seen as risky, then we get the issue of higher costs for infrastructure that is, has to be more resilient, as well as higher costs for capital that finances it. And finally, because water resources are limited, data centers that are highly dependent on water resources for cooling, say, are going to be feeling some friction there. And finally, in terms of the interactions between weather and the grid, um, interestingly, 1 in 2 grid disruptions is due to weather. And so, because of this, as our weather is getting more extreme on our warming planet, we know that grid disruptions are going to be on the rise, even just from that weather. And of course, because weather is getting more extreme in terms of demand, in terms specifically of heat waves, we also know that there is going to be more uncertainty in grid energy load, and a rise in that peak demand. Now, can the grid meet that? We don't know, but data centers are sitting at the intersection of those uncertainties. And so, following all of that bad news, I'm going to turn this over to David Grantham, who's going to present a story and a trajectory on how data centers can become more weather resilient on our warming planet. So, David, take it away.
Thank you, Hansi. It's a pleasure to be here with you, and thank you for such a thorough introduction from the weather standpoint. But let's begin to focus on the upside here, because I think we all are aware of the downsides if we're following this development in this space closely. So this is a quote. This initial quote is from Astro Teller, who's the CEO of Google X, and the AI journey should be based on bringing GE's bring good things to life. And I think if we keep that in mind and we try to understand and convey the value of AI and why there's such a dramatic, like an historic investment push into this space. That's the rationale, is all the potential benefits that AI can bring to our quality of life, our lifestyles, and all the things that you hear about in terms of the upside. This particular site is I'm in Oklahoma. Google's investing about $9 billion in Oklahoma in the next couple of years. They've got an existing site this in Pryor, and they're building a new campus in Stillwater at OSU, Oklahoma State University. Hansi, can you or Leo? There you go. Thanks. So this new data center, and you'll see in the slides that follow, this new data center captures what we're trying to convey in this adaptive resilience model, which is basically a geocentric, deep domain due diligence model that teaches us through ontologies how to integrate these domains into a single decision-making process. And so that's what we'll be working on in large part with the assistance of AI and high performance computing. And those are the features of this new campus. So it's a greenfield campus. It's brand new out of the box. They can build it just the way they want it to. And it gives cues for the existing data centers and how they can upgrade their facilities. So there's a lot of AI and high performance computing there for power dense, network intensive compute for inference and HP style workloads. There's Gemini-based large language models and their TPUs. This is critical for energy for people that are concerned about this and they want to know what the technological trajectory is on this. Is the latest Ironwood TPU has 30 times the power efficiency of the first generation TP2 in 2018. So that's a six-fold improvement in computing power per unit of electricity. And that's really important to understand as we go through these conversations at the community level and the grid planning level, where everyone's wondering, okay, what's the actual impact going to be in a 2035 scenario? And if we continue to follow this trajectory, which there's no reason to think that we won't, that's one of AI's strength, is its ability to innovate and make things smaller, quicker, and even larger at the same time. Energy stewardship is really a big part of this campus in Stillwater, a 40% reduction in energy use for cooling, 15% improvement in power usage effectiveness, which is a critical feature, a critical metric in terms of energy use at data centers. And the really cool thing is the AI continuously searches for novel optimization strategies. So you have AI running in the background, Gemini models or products running in the background, tracing this performance of the data center minute by minute, and then determining how do we respond? How could we respond to this environmental condition, or how could we respond to this resource scarcity in this given moment? Water stewardship and cooling technologies, those are real. Those are all the newer versions of them are just like any other technologies. They're better, they're more efficient, they're more cost effective. So next slide, please. So my model is an adaptive resilience model again, and it's this ontology of these primary risk domains. And so if you want the understanding of adaptation, at least in the sense of energy and the environment, is the retention of existing resources. So we have to maintain our existing resource base. And then as this energy transition, expansion, however you describe it, we have to exhibit coherence under change. So we have to understand that we're still dependent in very large measure on a fossil-based energy system, while at the same time integrating new technologies in renewables, advanced nuclear, advanced geothermal, and all those technologies that are in latter stages of R&D right now. Resilience is important because that shows that it's a persistent growth pattern. So this adaptation isn't just something that you do for a given event. It's a growth pattern, and it's a business practice. And it leads to innovation and new niche construction with new technology. So just like Planette has quantum inspired algorithms for their model, that would be considered an innovative new niche in software, in weather software. The adaptation resilience finance is really critical. You have to have the financial services that support agentic behaviors. And in this case, in a complex adaptive system, every actor is an agent. Every actor has the opportunity for agency to make a contribution, to be part of the conversation and part of the ongoing economic development. Next slide. So just specifically, a few high points regarding adaptive resilience for data centers. Operationally, and this all flows from Planette's software, is we're able to mitigate physical risk for extreme weather events. We can forecast water scarcity. Aging transmission infrastructure will be modeled on the Redwood AI side. The advanced cooling systems will be modeled on the Redwood AI side, and the AI-driven optimization will also be embedded in my model. Financially, it reduces long-term exposure to stranded asset risks, which is critical because if you've got a data center that doesn't function properly, or for whatever reason is inoperable due to community resistance or whatever, which is growing, I think we all know that, then you've got to have that financial protection. You've got to know how to manage those downtimes. For communities, again, this is a fragile license to operate environment that we're in right now because there's so many concerns that are growing in Oklahoma now. I mean, there are 3 or 4 new data centers that were announced just yesterday. Smaller data centers, not hyperscalers, but that's the key is this model can be used and these weather forecasting tools can be used for any size data center. It's not just for hyperscalers. Uh, next, next slide. Operational resilience, the reliability, logistics, and physics are critical. Power availability, potential grid failure, extreme weather, you've got to be able to understand when those may happen, what the potential risks are if they do happen, if there's an outage. Again, the Redwood AI adaptive resistance model is a geocentric model, so we focus on critical mineral supply chains and how we interact with our Earth systems in terms of natural resources. Thermodynamics and cooling has a lot to do with heat dome and wet bulb forecasts and adaptive cooling in advance of a drought signal, which is probably going to be very important this year, the way it's shaping up, because we're already in extreme drought in many parts of my state, Oklahoma. And I haven't looked at the drought monitor for the entire country in the US, but it's very dry in the plain states in particular. Next slide. Financial resilience is probably, we can't get anywhere if we can't finance these projects. They won't happen. We can't invest in adaptation resilience. So capital and insurance is a critical piece of this. You can project frequencies of 1 in 100-year events. You can avoid high risk designation. You can lower your capital and insurance costs by demonstrating adaptive resilience practices, energy markets, seasonal temperature anomalies, adaptive PPA structures, and arbitrage revenue from selling power to the grid, which is a critical feature of this because the data centers that are going to be the most effective and have the greatest community support are going to be the ones that actually strengthen the grid rather than weaken it. The geophysical economics are pretty straightforward. Precipitation intensity, flooding, soil stability, hydrology, avoiding emergency capex, and reducing OpEx with predictive maintenance during benign weather windows, which they do occur. And that's your window, that's the gap for making any of your predictive maintenance schedules. And that's critical no matter where you are. Next slide. Community resilience, I think this is really the focus right now, or should be the focus for everyone as we try to repair these frayed initial relationships. And we can do that by offering services to the community as the data center. My first work with data centers was went at a cooperative that had a fantastic data center room, and they were there for emergencies for their community. They were there for forecasts. They were there for any kind of community involvement that the community needed in terms of energy and environment and weather. And that's a really critical feature for data centers, and that can be done anywhere. Any of these data centers can do that. I know now data centers are typically just structures that process data, but they have the ability to move beyond that and become something much greater than that if they choose to do that. And obviously that's my recommendation. Energy equity is really important and geocentric stability. So that's really I think that's the crux of it. And that's what we're after is this community resilience so that as these data centers are built out, that we continue to have the support and we bring the communities along with us in ways that they deem important and that are most important, and that varies from community to community, of course. Next slide. I think it's Hansi's. Here we are. There you go.
Thank you so much, David.
Mhm.
Now we're going to switch to taking a look at what the long range weather has in store. So, particularly the forecast over the next couple of quarters. And so, before I do that, I just want to provide a brief overview of how long range forecasting is different from your usual 7 or 10 or 14-day weather forecast that you get on your phone. So, for long range forecasting, we use Earth system models, whereas for shorter forecasting, we use weather models. Weather models are based just on the atmosphere. The atmosphere has a very short memory, which is why these types of forecasts are limited to a couple of weeks. For longer range forecasting, we really have to use other components of the Earth system that have memory beyond the 14-day time horizon. So, this includes the ocean, this includes ice. This includes land surfaces. And so when we put all of this together, this is how we can get subseasonal and seasonal predictability. Predictability up to years into the future. Please keep in mind that when it comes to long range forecasting, we can't tell you an individual day that an event is likely to happen, but we can tell you, for example, say, is spring going to happen earlier this year? We can tell you, for example, is December likely to be colder than usual and therefore more amenable to snow or less likely? So you'll know whether you're going to likely have a white Christmas or not at your location. So, in other words, there are uses for this forecasting, but it is not day-to-day resolution. So that's really important to keep in mind. So now let's move forward to understanding a bit about this type of forecasting and what it shows us about what to expect over the next few months. So here is the mid-January forecast, and we actually have a really exciting forecast, which is that there's a polar vortex weakening that is going to be happening next week, and so that polar vortex weakening is going to create a cold snap over North America. And that cold snap, this is sort of what it's going to look like. So much colder than usual temperatures over the Midwest and the Northeast of the country. Now, if you are a data center in Oklahoma, if you're a data center in West Virginia, I know you might be like, whew, we're not going to be affected by this. The actual shape of this extrusion of Arctic air, it might shift a little bit. And so this is a time where data centers in these locations and definitely data centers in the Midwest will want to keep an eye on how this cold snap plays out. And please keep in mind the fundamentals over this entire winter have been favorable to polar vortex weakenings. And this is because of the state of the QBO. We have a negative QBO right now. And so because of that, we still have time to tango in February. Usually for these polar vortex weakenings, we get a few weeks of advance notice in terms of the forecasting. And so then from there, usually we get up to 30 days of notice for these cold snaps. So we'll be keeping an eye on it, and we keep our users updated on these kinds of happenings. So that is the cold snap story. Now, spring is just around the corner, even though it's January. And so, you might be wondering, what is that going to look like? Well, over most of the continental US and Eurasia, we're expecting an early spring, an early start to the spring. And what does this mean for energy? Well, one thing that it usually means is that runoff from snowmelt is probably going to peak early. When we have kind of these longer spring and summer seasons, we expect runoff to happen earlier in the year, which means then that the dry season, right, the summer dry season, that is going to be longer. And often this means a decrease in hydropower availability. So for regions where the energy grid is highly dependent on hydropower, if you have an early spring, you will expect a hydropower crunch by the end of the summer. So this is something to keep in mind for data centers that are in regions where the energy mix involves a lot of hydropower. From here, let's take a look at the summer. So we actually have some really fun sort of emerging weather that is likely going to show up in the summer, and that is that there's probably an El Nino on the way. So we've had this like extremely barely there La Nina that's been hanging out, and everyone is like, oh, it's going to become a real La Nina. Well, it never has, and it's just very weak, almost. Not very helpful for prediction. Well, it looks like we are going to be heading into an El Nino summer. So the likelihood of that has been, we've talked about it last year, and it looks even more likely now. So why do we care about this? Well, the Nino 3.4 index, which is the El Nino index, is the most skillful global predictor for extreme weather risk and property losses associated with that. So when you have an El Nino, it means that you have increased extreme weather in some places and less extreme weather in other places. So, in particular, California, the Southeast US tend to see more extreme weather. And then actually, the plains will see a lower likelihood of severe thunderstorms and severe hail. So these are some of the factors to keep in mind as we watch this kind of weather drama going on in the Pacific. And so the strength of this El Nino, we're going to keep an eye on it. It's going to depend a bit on these westerly wind bursts. Notice this giant thing right here. This is the blob. This is a huge warm patch of warm water that, if you look at some of our older webinars, we discussed this. And this is also helping to drive the long range weather. So there we have it, folks. Thank you so much for being here for our first webinar of 2026. And in a couple of weeks, we'll be back. So our webinars now are going to be bi-weekly. And so on January 21st, I'll be here with a full 2026 long range weather outlook. So we'll look in depth over the next 6 months and really break down sort of the physics of what's going on and what to expect. So, thank you so much for being here. And we are happy to answer any questions. And, you can find David and I both on LinkedIn. And both of us are very happy to have conversations and talk to you more about the intersection of weather and sensitive infrastructure. So, thank you so much. Thank you, Tim. Thanks for attending. Thank you, Chris. Thanks for attending. Okay. Well, if there aren't any questions, we'll go ahead and say goodbye. Have a great rest of your day, everyone.
Thank you, everyone.